Hi, everyone. Welcome. My name is Kevin White. I'm a public program educator here at Lowell Observatory in lovely Flagstaff, Arizona. And we just wanted to take a little bit of time to celebrate the launch of the Perseverance Rover earlier by NASA earlier today. This is going to be a remarkable. This is going to be an absolutely remarkable mission. We're all very, very excited about it. It's going to be landing on Mars. It's scheduled to land on Mars on February 18th of 2021. So we don't actually have very long to wait as far as these things go, just a few months. The rover, by the way, being named Perseverance, a lot of people have been nicknaming it Percy. And this observatory is actually founded by Percival Lowell. Percival Lowell actually built this observatory specifically to study Mars, and studying Mars was his main life's work for the last 20 years of his life. And so Percival Lowell would have been absolutely thrilled that this rover shares a nickname with him. So the Perseverance rover, by the way, was named via a NASA contest. And the winner of the contest, the person whose name won, whose essay won, was a student named Alexander Mather of Lake Braddock Secondary School in Virginia. And that's actually become a little bit of a tradition at NASA, is naming rovers via contest with Perseverance and also Curiosity and Spirit and Opportunity, all being named via contest by students. Which I think is a really lovely thing. Perseverance, everyone at NASA says, it was named a while back, but its name is over the last few months has really taken on a new and more important meaning, given the times both for all of us and also for the people working on this rover, especially because working on it under pandemic conditions, added a whole new dimension of challenge to what's really already very, very challenging engineering. Getting a high-tech SUV-sized piece of equipment to a whole other planet. And in honor of that, there's actually a very small plaque on the rover honoring medical workers who have been working during the current situation during the pandemic. So we have for you over the next few minutes three short videos that have been put together by some of our Lowell Observatory staff. First will be a brief talk by one of my fellow educators, Hannah Zigo, about the scientific mission of the Perseverance spacecraft. After that will be Lowell Observatory's historian, Kevin Schindler. He's going to be talking about Lowell Observatory's history and role in studying Mars. And finally, we have a special treat. One of our astronomers, Dr. Jennifer Hanley, will be talking about some of her work and how it connects to the Perseverance mission. Dr. Hanley studies salts on other planets, and that has and her work has really important implications for the potential for past or present or possibly even future life on Mars. So we'll go ahead and start with Hannah Zigo's video. In between the videos, I'll be taking questions. If you have any questions, just enter them in the chat, and I'll answer them as best I can.
Hi everyone, good afternoon. My name is Hannah and I'm going to talk to you guys a little bit about the Mars 2020 mission. So I'm a recent NAU graduate with an astronomy degree, and a lot of the research that I have done since I've been a freshman has actually consisted of looking at geologic processes that have happened on the Martian surface. And so Mars is very, very near and dear to my heart, so I'm super excited about this mission. So to kind of just get into it, the Mars 2020 mission, or the Perseverance Rover, is going to be the 5th rover that has ever landed on the Martian surface. And so the main goal of this mission is to see if there ever has been life on Mars, or has there ever been potential habitable environments. And so the Perseverance rover is actually going to land at a site called Jezero Crater. And so I'm going to talk about that a little bit later. But not only is a rover going to the surface of Mars, but actually a drone is going as well. So this is going to be the first of its kind. And so as you can see here, we have Mars 2020 or Perseverance, and then we have the drone called Ingenuity. And so Ingenuity is kind of a test concept. It will be able to see if we can actually fly around on the surface of Mars, which will help future missions that we will go to on Mars. So a little bit about the mission itself. So Perseverance will actually be launched on a United Launch Alliance's rocket Atlas V, and it's designed like Curiosity. So you can see it kind of looks like Curiosity in its form. It's, Curiosity was such an awesome rover, so why fix something if it's not broken, kind of thing. And so here are past sites that we have landed our rovers at. So I put little hearts where the rovers have been, and this kind of shows the other landers that have also been on the surface. And so we can see Perseverance here will actually be landing in Jezero Crater. And so a little bit more about the rover itself. And so this rover is unlike any other piece of technology we have ever sent to another planet. It is super, super cool. So I'm going to talk about some of the important instruments that we actually have on the system and what they will do. And so to start off, we have the MOXIE right here. And so MOXIE stands for the Mars Oxygen In Situ Resource Utilization Experiment. So basically what it's going to try to do is produce oxygen from the Martian atmosphere. And so if you don't know anything about the Martian atmosphere, it's consisted of carbon dioxide. And so MOXIE will try to convert that carbon dioxide to oxygen, kind of like how trees do. And so this will be very, very important for future missions. If we ever want to send humans to Mars, we're actually going to need this technology. And so this is kind of the stepping stone for future, hopefully, human missions. And so that's MOXIE. Next up, we have Mastcam-Z. And so the Mastcam is actually a video/camera device that's going to take HD videos, panoramas, images, all of the Martian surface and features in the atmosphere, and it will be able to zoom in on different rocks, and it will be able to pick out the best rocks. So maybe something looks interesting to planetary scientists and geologists, or see if something looks potential for life to be harbored in it. And so it's basically like the eyesight, and it will hunt for places for life, look for water signs, and it has very, very sharp vision. Okay, so next up we have the MEDA, or the Mars Environmental Dynamics Analyzer. And so what this instrument will do will study the dusty environment. It will help predict the weather, can measure radiation, water vapor, and potentially show the weather's impact on the Martian surface. And then next up we have PIXL. So PIXL is the planetary instrument for X-ray lithochemistry. And so PIXL will be able to measure the chemical makeup of rocks at a very, very fine scale. It could possibly detect signs of past life, and it will be able to see super, super small details, which is really important. All right, just a few more to go. We have the RIMFAX, or the Radar Imager for Mars Subsurface Experiment. And so this is going to be a very cool instrument, as it will be able to see geologic features under the surface with ground-penetrating radar. So just like explorers probe below the Earth's crust, and they can see, detail of these unexplored worlds that lie beneath the surface, RIMFAX will be able to do that. So it can detect ice, it can detect water, it can look at potential caves and features underground. And so there has never been a radar tool like this sent to Mars before. So it'll be very, very interesting to see the data that we get back from this. Okay, so next up we have SHERLOC. And so I like this acronym because it reminds me of Sherlock Holmes, and that's exactly what it is named after, because SHERLOC is the scanning habitable environments with Raman and luminescence for organics and chemicals. Woo, that's a big one. So Sherlock is basically going to be like a detective, and it'll be able to look through the Martian surface and environments and be able to make these fine-scale detections and measurements of organic molecules and potential biosignatures. And Sherlock actually will be holding test spacesuits that we will be sending to future Mars missions if people ever go. And so it'll carry the spacesuit material, and it'll see if they can hold up to the Martian environment. And so it'll also collect clues, and Sherlock has this UV laser, this ultraviolet laser light, to look for organic chemicals, and kind of the same way that modern crime scene investigators look for forensic clues. So that's why, kind of got the Sherlock there. So it's going to be a very, very interesting instrument, and if you can see on the rover, it's at the very, very end at one of its long robotic arms. Okay, so last but not least, we have the SuperCam. And so the SuperCam will be able to identify chemical compositions of rocks and soils, and potentially including their atomic and molecular makeup. And so it'll be able to find great rocks that have potential to have life in it, and look for life preservers and stuff like that. So this whole entire mission in itself is to look for evidence of past extant life on the surface of Mars. So I'm super excited for everything that's going to be going on with these instruments and what they're going to be able to do and the information we're going to be able to get back from this. So I'm so excited. I know I've said that a lot, but I'm super excited to see if we find anything interesting on the surface of Mars. And so just a few other tidbits about the rover itself is it will actually be taking core samples. So it has 43 containers that it will be able to drill into the surface and put that material into these containers. And so it's going to try to take 20 to 30 samples. And after those samples are collected from the drill, the rover will actually store them inside the underside of the rover. And once it has collected enough samples, it will find a place where it will deposit these samples on the surface. So hopefully a future mission will be able to go to Mars, pick up these samples, and then bring them back to Earth. And so that's going to be the first mission of its kind. It's still in the works, but really cool concept. And then one other thing is that this rover will actually have 2 microphones attached to it, one to the SuperCam, and I have no idea where the other one is. I believe just somewhere else on the rover. And so the point of having these microphones on the rover is so we can actually hear the sounds of Mars. And so when the SuperCam uses, some of its lasers to fire at rocks, it will be able to detect this like pop noise. And just from hearing this pop noise from the rocks, we can actually tell kind of like the hardness of the rock, kind of the material of the rock. It tells more about the geologic context of what it's shooting at. And another thing is we have never actually heard the landing and the whole entire process of these rovers reaching to the surface of Mars. So we'll be able to hear the whole entire experience, which is super, super cool. Okay. And so I know I didn't really talk about it too much, but I'm just going to briefly touch up on this Ingenuity helicopter drone. And so, like I said, it's just a test. It's not really going to do any data or any science research, but it will be the first ever off-world helicopter that we have had, and it will only fly 5 times during its trial period for no more than 3 minutes each flight, and it will only go 3 to 10 meters. And so basically, its whole point is to see if we can actually fly these drones or these helicopters on other planets, see if the technology works out well, and then potentially do it for future missions, go anywhere else to other bodies in the solar system, and see if we can just have a little drone helicopter flying around and get more data. And so the only thing that this will be doing besides testing out if we can testing out if the technology works, is potentially looking at other sites that Perseverance will be able to go to in the future. And so on that topic, where Perseverance is going, is it's actually landing at a site called Jezero Crater. And so here is a view of Jezero Crater. And so once upon a time, a big body hit the surface of Mars and created this crater. So as you can see here, we have this nice round crater here. We have some other impact sites inside the crater. And where this kind of rim, where the crater is, we have a past riverbed that actually flowed into this crater. And we have an ancient delta here. And then we think Jezero Crater may have been an ancient lake. And so there is all this evidence to support that water has existed at Jezero Crater, not only looking at this past riverbed and this past delta, but looking at the materials in Jezero Crater. So just from orbital data, there is this instrument called CRISM that can kind of look at the geologic makeup of these areas. And what we have actually seen is that Jezero Crater has these clay-bearing units, and we know that clay is only formed in the presence of water. And so with this wet, period, there is the potential for life to have existed in Jezero Crater. So that's why it's a very captivating spot to go to. So where this circle is on Jezero Crater is the potential landing site for Perseverance. And so the first thing that Perseverance will look at is actually the lake bed. So it will look at the lake bed, see if we can find anything interesting there, and then it will make its way up to the delta. And then once it goes to the delta, it will make it to the crater rim. And so through this whole entire process, we're going to be looking for remnants of extant life that may be fossilized or preserved in these rocks or in these clays in the crater. So Jezero Crater lies within the Isidius Planatia region of Mars. And so a little bit of a closer up region here of Jezero Crater where that ancient delta is and that riverbed. And so you can see, it really looks like, water was flowing there in the past. And so it's a very, very interesting target for us to see if in these wet conditions in the Mars past, if there, has ever been life. And so that's all that I really have for you guys. If you guys have any questions, I will be answering some in the comments. Something I left out, Mars 2020 will actually land in 2021. So it should reach the surface of Mars in February. And so maybe we'll be doing something in February for the landing. So stay tuned for that. But thank you guys very much. Yeah, thank you.
Thank you, Hannah. So a few questions from the chat, but first I think we're going to watch a brief clip of the Perseverance Rover's rocket lifting off, which happened earlier this morning. So we'll go ahead and play that right now.
The Perseverance Rover headed to Mars, ready to ride a column of fire and smoke on its way to the red planet.
And while we're waiting for that,
Mars continues.
One of the question is
launching the next
whether there's
of robotic explorers to the red planet.
So one question is whether there's water in this crater. We think that there was water in this crater.
TU has gone to closed loop control.
Conditions on Mars are right now not very conducive to.
And we have successful separation of Mars 2020 with the Perseverance Rover.
Playing.
We now have an acquisition of signals, and the years of blood, sweat, and tears from every person who worked on this mission is now realized.
So, all right, so we might be having a small technical issue. We'll get that clip for you here in just a few moments. In the meantime, conditions on Mars right now are not very conducive to liquid water. Its atmosphere is basically too thin. So water goes straight from being a solid to a gas on Mars, similar to the way that dry ice works here on Earth. And when we get to Dr. Jennifer Hanley's talk in a few minutes, she'll talk about that fairly extensively. And yeah, we'll get that video. We'll try to get that video up and running for you in just a few minutes. So we think that we think that Mars' atmosphere used to be much thicker than it is right now, and we think that there was abundant liquid water in the past. But Mars' atmosphere over the last few billion years has gotten much, much thinner. We think what's probably happened is that the radiation from the sun has very, very slowly, like over hundreds of millions of years, stripped atoms out of Mars's atmosphere and thinned its atmosphere very slowly over billions of years. And currently, Mars' atmosphere is only about 1% as thick as the Earth's. And that means that water boils at a very low temperature on Mars. It is possible that some like very thick salt water might exist still on Mars, which again Jennifer Hanley will talk about. But we think that Jezero crater used to be filled with water. It's not anymore, but that idea that it used to be filled with water is really tantalizing to scientists in a lot of different ways. So that's why we're sending Perseverance there. Okay, so I think we're ready to play that rocket video now. So we'll go ahead and do that.
The Perseverance Rover headed to Mars, ready to ride a column of fire and smoke on its way to the red planet.
And liftoff. As the countdown to Mars continues, the perseverance of humanity launching the next generation of robotic explorers to the red planet.
And Atlas TU has gone to closed loop control, standing by for SRB burnout shortly. And we have successful separation of Mars 2020 with the Perseverance Rover.
We now have an acquisition of signals, and the years of blood, sweat, and tears from every person who worked on this mission is now realized as Perseverance makes its way to Mars.
All right, so we had a couple more questions, and then we'll get to Kevin Schindler's talk. So one person, we got a question whether the launch already happened, and the Perseverance launch already did happen. It went very early this morning. And as you just saw, we do have video, and you can catch much more extensive video of it on NASA's website. I believe this shouldn't be your last chance to watch a rocket go up, or even the NASA rocket go to that's going to Mars. Windows where the Earth and Mars line up, so we can send a rocket there most easily, about once every 2 years. And I believe it is still NASA's policy to send at least one mission to Mars every time that such a window happens. So if you just wait 2 years, then we'll be almost certainly sending another rocket to Mars, and there will be more space missions that NASA will send up in the meantime. We also had a question: what colors do the craters in that photograph represent? What do the colors in that crater represent? And I believe that in the one with all the vivid purples and stuff, I believe that's a false color image. In a true color image of that, the colors will still be very interesting, but they'll mostly be different shades of red. Mars has a lot of rust in the dirt on it, so it has lots of so since rust is red, most of the surface of Mars has that sort of reddish color coming from that iron oxide, that rust that covers its surface. The colors in the crater that we saw in Hannah's program represent elevation. So that was a false color image, and the different colors in that image represent the different elevations on Mars. All right, so our next program will be our historian, Kevin Schindler, who will talk for a few minutes about the history of Lowell Observatory's studies of the planet Mars.
Mars has been a focus of research at Lowell Observatory for most of our 126-year history. But the story really goes back even before the founding of the observatory to 1877. And I want to talk about this and then the ensuing history of Mars research at the observatory. So let me start a program here. Get it up. So in 1877, there was this particularly favorable opposition to Mars when Mars was closer than at other times. And during this time, an American astronomer named S.F. Hall discovered Phobos and Deimos, the two moons of Mars. It was the same opposition. On the other side of the world, an Italian astronomer named Giovanni Schiaparelli was looking at Mars, and he detected these linear features. You can see some of these darker features on here that are kind of straightish. Some of them curved some, but fairly linear. And he called them canali, which in Italian it's interpreted as channels, some sort of channels, perhaps where water ran through them. Well, this really captured a lot of people's attention. And as the years went on, some astronomers around the world guessed, well, maybe these weren't natural features, maybe these are made by some sort of intelligent life. One of these people that thought this was a fellow named Percival Lowell. And we know his name very well here. He's shown in this picture, the second from the left. Percival Lowell grew up in the Boston area, studied mathematics at Harvard. He had an interest in astronomy all his life, but he studied mathematics in college. He got out of college, graduated, worked for the family business for several years, and then he went overseas and spent 10 years in Korea and Japan. When he came back, he decided he wanted to go into astronomy because he had read more about these canali, and he took to calling them just canals because he thought they were evidence of intelligent life. Now, he wasn't the only one to call them canals. He wasn't the first one to think they might imply some sort of intelligent life, but he was certainly the loudest as time would go on. And we'll talk about that a little bit here. So 1894, he decides to found his observatory specifically to study Mars and prove the existence of extraterrestrial life and intelligent life on Mars. He borrowed a couple telescopes initially, and then in 1896, he purchased this 24-inch refracting telescope, which still stands at the observatory today. And he started observing Mars during every opposition, every couple of years, and made these very detailed drawings. And he saw these canals, these straight features, but he saw many more. Every time he observed, he seemed to see more and more of these things. And it's really pretty fascinating to look at what he was interpreting, partly because his idea of life on Mars is more than just the canals, because he was studying how planets develop. And he believed, like some other astronomers, that planets evolve, just like biological species evolve. If we remember in 1859, Charles Darwin came out with a theory of evolution in which he explained biological changes over time. Well, Lowell and others thought that you could adapt this to other stuff, non-living things. And so for Percival Lowell, planets evolve. You start with young planets that are very gaseous. They still have a lot of gas around them, like Saturn and Jupiter and Uranus and Neptune. As they age, a lot of those gases dissipate, and you're left with kind of a moderate aged planet. And he categorized Venus, Mars, and Earth as this. And then as time went on, atmospheres went away, the planets dried up, and you became Mercury, just a dead planet. But in this stage of evolution, in this middle stage, we had Earth, which has life, and you had Mars, and Percival Lowell thought, well, Mars is in the right stage of evolution, so there's probably life there. These canals are proof of that life. And so he wanted to study these and document as much as possible what he saw as proof of life. Another reason we find this so fascinating is because we know today these canals don't exist. they're some sort of optical aberration, and yet the story that Percival Lowell made out of them really inspired so many people to want to learn about Mars, both scientists and non-scientists. And just briefly, what he believed, and when I say he believed it, he wasn't the only one. He wasn't the first one to believe there was intelligent life based on this evidence of the canals, but he was the loudest. And he was perhaps the most eloquent because he not only wrote the results in scientific publications, but he gave lectures and wrote popular books that really popularized this whole thing. But his idea was that you had polar ice caps, like this big white splotch, and the middle of the planet was drying out. So this intelligent life built these canals to bring water from the canals down to the rest of the planet, water this dying planet. And then if you look here, you see these little circular areas, little dots. He called those oases, which are kind of like little population centers. So the ideas were really compelling and really got a lot of people's attention. He like I said, he wrote popular books. He was quoted in newspapers frequently, and he was an expert. He was seen as, so whatever he said must be true. And so this really galvanized newspapers. This was great stories for newspapers on this life on another world and so on. And it's interesting because Lowell, even though his ideas were wrong, he wasn't a crackpot. He came from a mainstream family. He was ultra intelligent. He was a driven person, but he just made these ideas. There were a lot of assumptions involved with them. The stories themselves, his explanations were very compelling, but those canals just aren't there. But be that as it may, Percival Lowell really popularized this idea of life on Mars. In the media, he wrote several books which make really great reading. And so he inspired scientists to want to either prove that there's life there or disprove it. But he also inspired future generations. And I should point out also that a lot of scientists thought he was full of baloney. These things aren't there. We can't see them. We don't know what he's seen, but they're not there. His theories aren't logical in a lot of ways. But be that as it may, Lowell really, really inspired a lot of people, both scientists and non-scientists. Robert Goddard, who went on to invent the liquid fuel rocket, he's shown right here. He remembers as a youth seeing Percival Lowell give a program and was just so inspired by it, he wanted to go into science and learn about space. So other scientists like Carl Sagan, who was one of the great spokespeople for astronomy for the mid-20th century, and he did a program called the Cosmos. And this picture is kind of fuzzy because it's a still from the Cosmos series. He's sitting at Percival Lowell's Clark telescope. He was inspired by Percival Lowell, and just how interesting his ideas were, and he wanted to study Mars largely because of this. Non-scientists, you had science fiction writers like H.G. Wells and Edgar Rice Burroughs. Percival Lowell built this consciousness that there's life on Mars. Whether it was true or not, in hindsight, doesn't matter because he built this consciousness, and writers wrote about what was in the public mind. And Lowell had built such a strong case for it. It was believed there was life there, so the writers of the time crafted these great novels based on these Lowellian thoughts. War of the Worlds and the Princess of Mars series are still classics and were later made into movies. And so this really, the early work that Lowell did, even though he was wrong about the canals, wrong about life on Mars, he really generated a lot of interest. And he did a lot of good science also, a lot of really detailed observations. But I think the big legacy he left is inspiring people to want to learn more, to want to see more of the universe. Another legacy of his was hiring some really great people to work with him. One of these or two of these actually came from a very large family from Indiana. The one in the back row, third from the right, his name is Vesto Melvin Slifer, went by VM. And VM would come to Lowell Observatory and make fundamental discoveries about the universe and really discover the first evidence of the expanding nature of the universe. His younger brother, one of his younger brothers, all the way on the left here in the second row, is Earl Slifer. He went by EC. EC Slifer came to Lowell Observatory initially to help Percival Lowell look for a ninth planet, which led to the discovery of Pluto. But he really specialized astrophotography, and he became a world expert on Mars, kind of paralleled with Percival Lowell. But when Percival Lowell died in 1916, E.C. Slifer really took the mantle as the Mars expert, not just at Lowell Observatory, but one of the great ones in the world. He used Percival Lowell's Clark telescope in Flagstaff, but he also traveled elsewhere. He took 3 different expeditions to South Africa. So this is not Flagstaff, this is South Africa, Bloemfontein. And he observed there in 1939 and twice in the 1950s. And at one time, he took more pictures of Mars than anybody else in the world. He really became an expert with it. And he recorded really incredible detail for the time because he really spent a lot of time playing with different emulsions and filters and plates. When I say plates, those are glass. It's how they took pictures. That's how they recorded images. They could sketch in details, they could make their own sketches, but astrophotography was becoming very important to astronomy, and so astronomers took pictures. And it's maybe not how we would think. This is an early camera. This is on that telescope in South Africa. This whole tube right here is a camera. So instead of having an eyepiece at the base of the telescope, you take that off, you put this tube on, and the light passes through and comes to a focus right down here where E.C. Slifer would put one of those plates in. And a plate is a piece of glass that had emulsion on one side, so it's like a big piece of film. And that's E.C. Slifer on the right. And so Slifer mastered astrophotography, and one of the important things he did was to combine a lot of images he took. And so he was one of the forefathers in astronomy of what we call today as image stacking, in which he took many images, put them together, and by putting them all together, you could get, a better picture than just one on its own. And so he really made fundamental improvements to our knowledge of astronomy and Mars in particular. Here he is in the 1950s down to South Africa with an assistant. This particular expedition was sponsored by the National Geographic Society, and he's holding one of these plates. And you can see there's more than a dozen little images on there. He would use the same plate to take multiple images. Again, there's like a big piece of film, so he'd capture an image, then move the plate over, get another image, so that he could get as many as possible on that plate, just to conserve the use of the plate. So he really made fundamental changes to astrophotography, and this idea of image stacking in modern astronomy goes back to him. So that was really pretty important stuff. He was such a world expert that in the 1950s, when Walt Disney was putting together some of the first educational TV programming, he had opened his Disneyland park in California, and then he created television programming really to advertise that park, to inspire people to want to go there. But one of the early programs he did was called Mars and Beyond, and he brought in Wernher von Braun, who was a rocket expert, who was considered the father of the American rocket program that led to astronauts going to the moon. So he brought in Wernher von Braun, and he also brought in E.C. Slifer as one of the world's leading experts on Mars. And here's a still from that episode of the late 1950s of the Disneyland show. And E.C. Slifer is in it. You can still find this on DVDs. This is a still of that. And I like this picture because E.C. Slifer didn't wear glasses. The studio put glasses on them because they thought it made him look more studious. But anyways, Slifer did this program, and I think it brings up an important point. As we talked about with Percival Lowell, he did the science and wrote up the results in scientific publications and such, but he really popularized science also. He helped educate and inspire people, and that tradition has continued through the years. E.C. Slifer doing programming for Disneyland, and this kind of stuff continues today with name an educational program in TV, and they've probably done something about Lowell Observatory. So it's an important part of our mission is doing the science and then sharing the results with both the scientific community and the general public. So Mars is just the classic example of that at the observatory. So E.C. Slifer worked at the observatory into the 1960s, and it was toward the end of his time working when a program came to Lowell called the International Planetary Patrol. And this was essentially a group of observatories from around the world that would use similar sized telescopes to constantly observe planets in our solar system, looking for changes in the atmosphere and surface features and such. And so this was a really important program in the 60s and 70s especially. And we had people like Chick Capon, shown here on the left. And Chick Capon this is great. There's that classic picture of Percival Lowell I showed earlier, kind of the iconic picture of him and his telescope. Chick Capon here has recreated that picture, dressed just like as Percival Lowell had. Chick Capon is another longtime Mars astronomer. He was actually a student of Clyde Tombaugh. After Clyde Tombaugh discovered Pluto here at Lowell Observatory in 1930, he later went to New Mexico State University, and it was there that Chick Capon was a student of his. And then Capon came to Lowell Observatory and worked for several years as part of this planetary patrol. So the patrol is really an important program, again, for advancing our knowledge of Mars. And I think a good example of one of the things they did was observing Mars, for instance, in 1971. They periodically during these oppositions would observe how the dust moved across the surface of Mars. And in 1971, we can see these pictures from September 21st, 22nd into October. If we look at this first image, you can see relatively a lot of detail. But then look as time goes on, these features are getting obliterated, and you can't, by over the last two pictures, you can't see anything because this huge dust storm was covering Mars. And this was a pretty interesting thing. The timing was interesting. The observation was done by this fellow. His name was Leonard Martin, and he's standing at the Clark Telescope. It was important because the Mariner 9 was flying out to Mars, and Leonard Martin and his colleagues said, hey, there's this dust storm going on. When the spacecraft gets there, there could be a problem. And sure enough, when Mariner 9 got there, it was the first spacecraft to orbit a planet, but when it was first orbiting Mars, you couldn't photograph anything because this dust storm was covering everything. The satellite was above this dust storm. Eventually, the dust storm settled down, and Mariner 9 was able to get good pictures. But the work by Leonard Martin helped prepare scientists that this is going to be covered up for a while. Now, this is a classic picture. I think it's a great picture because the telescope is pointing at Mars, but it's a fun one to show also because if you've watched the show The Big Bang Theory, season 1 of that show had this poster on the door. I think it's a closet door, and we can go back here. That's a picture of Leonard Martin with the Clark Telescope in the Big Bang Theory TV show. So that's Leonard Martin right down there. So again, kind of this, I think one of the interesting things about Lowell is we have such an important scientific heritage, but also this cultural heritage from education, from educational programming, even in pop culture with things like this. So that's in brief a legacy of Mars research at Lowell Observatory. And when Leonard Martin retired, we didn't have any Mars research going on for a little while. But then thankfully, Jennifer Hanley came on board, and she's carrying the mantle. The work started by Percival Lowell, continued by E.C. Slifer, by the Planetary Patrol. And now Jennifer is doing incredible research on Mars. So I'm going to end here, and then Jennifer can talk about her research. So thank you very much. Thanks for joining us today. And we're excited about Perseverance and the next stage of Mars exploration. Thank you.
All right, thank you so much, Kevin Schindler. So what I think we'll do now, well, first of all, thank you all for joining us. For anyone just now joining us, this is Lowell Observatory's celebration of the launching of the Perseverance mission to Mars. My name is Kevin White, and we're in the process of playing a few videos about this mission. The last one was Kevin Schindler, who was our historian, talking about the role that Lowell Observatory has played over the last century and a quarter in about the studies of Mars. So what we'll do now is we're going to play, for anybody who missed it, a brief clip of the rocket launch earlier this morning of the Perseverance mission that went early this morning. And then I'll take a few more questions, and then we have Dr. Jennifer Hanley, who's one of our astronomers here. She'll be talking about her work and about salts in the solar system and its scientific implications and its connection to the Perseverance mission. So as soon as we're ready, we'll go ahead and get that rocket clip playing again, and then we'll take a few more questions.
The Perseverance Rover headed to Mars, ready to ride a column of fire and smoke on its way to the red planet.
And liftoff. As the countdown to Mars continues, the perseverance of humanity launching the next generation of robotic explorers to the red planet.
And Atlas TU has gone to closed loop control, standing by for SRB burnout shortly. And we have successful separation of Mars 2020 with the Perseverance Rover.
We now have an acquisition of signals, and the years of blood, sweat, and tears from every person who worked on this mission is now realized as Perseverance makes its way to Mars.
All right. So a few questions. We had one question about whether it's for Kevin Schindler specifically, about whether it's possible that there might have been life on Mars in the past. And Kevin Schindler says, the jury is still out on whether or not there was once life on Mars, and the search for such ancient life is, as we've heard, a core goal of Perseverance. Personally, I'd be thrilled if Perseverance does detect some sort of evidence for life. If some ancient life is detected in Mars, it would probably be microscopic. Kevin Schindler, I believe, also wanted to relay one other thing. He says, have you been to the restaurant on Mars? The food is out of this world, but the place doesn't have much of an atmosphere. Another quick question. Somebody asked, DP asks, did Percival Lowell learn that he was wrong about the canals during his life? And the answer is not really. Honestly, there was starting to build up a little bit of evidence that Percival Lowell probably wasn't right about most of his ideas about Mars before the end of his lifetime. Mainly, astronomers were pointing spectrographs which measure colors at Mars, and we're starting to realize that Mars's atmosphere is pretty thin. But the evidence wasn't really conclusive for basically about another 60 years until we started actually sending spacecraft to Mars. And basically right up until then, there were people that, including experts, that thought that people, including experts, that thought that these lines might be real, and there were still people that thought that they might be canals, or even if those weren't canals, then there might be some sort of macroscopic obvious life on Mars. And we still do, in terms of microscopic life, we still do hold out hope. But yeah, the Percival Lowell still went, as far as we know, he went to his grave still believing. And he did absolutely go to his grave still publicly expressing that there was that these lines that people were seeing on Mars were canals of some sort. Okay, so do you have another question? If the escape velocity of Earth is 25,000 miles per hour, why is the rocket only going 6,000 miles per hour before it was parked? I'm afraid that's not a question that I know the answer to, but I can try to look it up, and if I find the answer, I'll put it I'll answer it later or put it in chat. Let's see, do we have any other questions before we go on to the next program? I think that's it. So our last talk for this program is Dr. Jennifer Hanley, and she'll be talking again about some of her work on salts in different places in the solar system, on Mars in particular, and some of the implications for that in terms of our expectations for the possibility of life on Mars.
Well, thanks for joining us. My name is Dr. Jennifer Hanley, and I am a planetary scientist at Lowell Observatory. And I'm going to talk a little bit about my research, salts on Mars, and how that's related to the Perseverance Rover and what that can do to help some of the research we're doing. So first I want to talk a little bit about where NASA has been before. NASA's been pretty successful with landing on the red planet. Up here you can see we have the Phoenix lander that landed in the North Polar regions of Mars. The rest of the missions have been in this generally equatorial region. You can see Curiosity and Gale Crater over here, and Mars 2020, also known as Perseverance, will be landing in Jezero Crater. Jezero Crater is an exciting landing location because it used to hold a lake. So you can see here on the left, the river input, then it filled up this lake, and then it reached the crater rim and flowed out on the right here. If we zoom in on the delta formed from the inflow of the river and the deposition of sediment, we can see some really interesting features here, including clays and carbonates, which are very good for preserving organic material. So Perseverance, or Mars 2020, will be landing in this region right next to the delta. So you can know that there used to be water on Mars, but current conditions do not support liquid water. If we look here at the phase diagram of water, on the x-axis we have temperature, and on the y-axis that's pressure. So 1 atmospheric pressure, that's what we have at sea level on Earth, and that means that the freezing point here is 273 Kelvin, and the boiling point is 373. And so down at Mars, 0.006 atmosphere, you can see that really we can barely get into the liquid range. It basically will boil rather than becoming a liquid. And even if we could get to the temperature regimes, it doesn't really support that very well. You can see here that the highest temperature we get is in the middle of the day, at the height of summer, at the equator, and that's about 20 degrees Celsius. On average, Mars's temperature is about 220 Kelvin. So this is where salts come in. Salts are important because they can affect the stability of liquid water by lowering the freezing temperature. They also increase the boiling point and lower the evaporation rate. So if salt is present in the liquid, then it actually increases the stability range by both lowering the freezing point and increasing the boiling point. Sorry, lowering the freezing point, increasing the boiling point, and lowering the evaporation rate. To see that visually, we have this comparison here of pure water on Earth's surface. You can see, of course, it freezes at 0 Celsius and boils at 100 degrees Celsius. That is at sea level. If you live up here in Flagstaff, then you see that we boil water at 93 degrees Celsius. That's why we have all these high altitude baking books, because we're cooking at a different temperature when you're boiling water. So if we compare that to Mars, we see that it still freezes at 0 degrees Celsius, but it actually boils at 10 degrees Celsius. That's again due to the difference in atmospheric pressure. However, if we add salts, and in particular magnesium perchlorate salts, we can increase the stability range by lowering the freezing point to minus 67 Celsius and also increasing the boiling point to 24 degrees Celsius. So a little bit about these chlorine salts. You can see here that we have a few different types. We have chlorides, which most are familiar with as sodium chloride, NaCl, or table salts. But I'm also interested in some of the oxidized chlorine salts, chlorate and perchlorate. And when they associate with magnesium, calcium, sodium, they form salts. So where are perchlorates found? They've been found by NASA's Phoenix mission. As I pointed out, that was in the North Polar region of Mars. It was also identified by Curiosity in Gale Crater. And we expect that it is globally distributed, although it hasn't been detected on the surface in many places because we don't have too many landers. On Earth, perchlorates are pretty rare. They typically only accumulate in very dry or hyper-arid environments like Antarctica, the Atacama Desert, or the US Southwest. And they're formed by oxidation of chlorine by UV radiation. Typically that is atmospheric, but it can also happen on the surface in ices. So why do you care what kind of salt is actually present? Well, different salts lower the freezing point by different amounts. So sulfates and carbonates tend to be a little bit warmer. They don't depress the freezing point quite as much, but chlorides and chlorine salts depress it further, and all the way down to about 200 Kelvin in some instances. And chlorine salts can be a source of energy too. So in addition to extending the stability range, perchlorates and other chlorine salts are extremely hygroscopic, and their hydration state is closely tied to both temperature and relative humidity. So we can see this by watching this video of this process called deliquescence. Basically, you have this magnesium perchlorate, 6H2O, that's the white stuff in the beginning of the video, and it's actually absorbing the water vapor. It's in 75% relative humidity. It's absorbing the water vapor out of the atmosphere and turning into liquid droplets. And you can see it starts to become more clear as the salt is dissolving into this liquid solution. And so this is all important because since the different salts affect the stability of water in different ways, it therefore affects the habitability of the liquid in different ways. And if we think about, modern sites or, what is currently happening on Mars, if we look at the salt stability, we can start to understand, could water droplets be forming today? But it can also tell us something about the ancient sites and what the conditions were when the salts were formed. So what type of lake was it? Was it very salty? What was the evaporation rate and the temperature of it, if we can distinguish between the different salts? And of course, so this all factors into the habitability, which is a key point that Perseverance is trying to search for, is habitability and habitable spots. So if we think about extremophiles or halophiles, salt-loving organisms, there's lots of examples of this type of organism. Here we have Haloarchaea and cyanobacteria that occur in halite crusts, as this picture would be a halite crust. It's one of my favorite stories or papers, I guess, is looking at the Atacama Desert over the course of a year. These researchers measured the amount of times that a rainfall event occurred. So how many times was pure liquid water on the surface? And that only happened once in the entire year. However, it reached above 75% relative humidity, which is the humidity required for sodium chloride or halite to deliquesce, turn into a liquid. That happened 57 times in the course of the year. So the organisms living inside these halite crusts had 57 liquid events with salty water compared to just one rainfall event for the organisms living outside the halite crusts. That's a difference of 214 hours versus for the salty organisms versus 6 hours for the pure liquid water ones. So the organisms actually utilized this deliquescence event to uptake more liquid. And we also know that microorganisms can survive and even thrive in different chlorine, magnesium chloride, and sodium chloride conditions, and even down to some cold temperatures too. And perchlorate and chlorate reducing bacteria have been found to utilize the extra oxygen on these oxidized chlorine salts. So how will Perseverance help all this? Well, so here's some of the instruments, and Mastcam Z is zoomable panoramic cameras, so it can look and potentially see if deliquescence ever occurs. It could see liquid droplets on the surface. It also has these imagers that can look in different wavelength regions, and so we might be able to identify salts in that way. MEDA, the weather station, that's going to measure temperature and relative humidity, so we can monitor for conditions where we think that deliquescence might occur based on different salt types. SuperCam is a new version of Curiosity's ChemCam, so that has the laser-induced breakdown spectroscopy. So it actually will shoot a laser at the rock, at a standoff distance, and it has a visible near-infrared spectrometer as well as a Raman spectrometer, so it can actually understand both the elemental and mineralogical components of whatever it's zapping, whether it's a rock or maybe a salt deposit. So we can start trying to identify the salts in that way. Sherlock is also a Raman spectrometer. It uses a UV laser wavelength, and it's also on the arm of the rover, so it can actually get very, very close and look at fine scale details and identify the salts in that way. And lastly, Pixel is an X-ray spectrometer, which also might be able to help in detection and differentiation of the different salts. So I'll just summarize briefly. Chlorine salts are important for the habitability, and they are globally distributed across Mars. We do expect to find them in Jezero crater, and Perseverance will help identify those different types of salts. And it really is important to differentiate between, chlorine versus sulfate salts for understanding the stability of water and the habitability of that water. Whether we're talking about current environments today, whether we could see any liquid droplets, or even understanding the history of the lake, for instance, evaporation rates and temperature. So with that, I will say thank you very much, and go Perseverance.
the rocket. Pardon me. We got a question a few minutes earlier about the velocity of the. Oh, good. Guess there was a quick technical issue, but we should be good now. So we got a question a few minutes earlier about the velocity of the rocket. I did check into that real quick, and it is a multi-stage rocket. So it's a rocket with basically a big rocket with a smaller rocket inside of it, and that has a smaller rocket inside of that, and so on. And I'm not sure how fast they each get in the progression, but by the time they get to the end of it, with the smallest rocket, which is the one that'll actually be taking the Perseverance Rover to Mars, it is going at about 25,000 miles an hour. So by the end of the progression, the rocket will actually be going a little bit faster than the Earth's escape velocity. We had another question about Martian dust storms. And the answer is, even though Mars's atmosphere is very, very, very thin, it's about 1% the thickness of the Earth's. Wind speeds on Mars can get very fast. So you have this dynamic where you have very fast winds in a very thin atmosphere. And so basically what that ends up meaning is that the Martian winds, they have a hard time picking up anything very big, even very sizable grains of sand or stuff like that, that it can't really move very well. But there's lots of sort of much thinner, fine dust on Mars, and so what happens with the dust storms is that this very thin but very fast wind will pick up a lot of the very, very small pieces of dust, and it'll pick that dust into the Mars, pretty high into the Martian atmosphere, and this dust for periods, for fairly substantial periods, can cover basically the entire planet. And there's actually a Martian dust storm just about this time last year that basically did cover the entire planet. And those happen once every few years. So another question: what is the plan for Perseverance long term? Will it stay in this canyon or move on? I'm not sure they've completely decided all of that yet. And that's one of the cool things about these sorts of rovers, is that they can kind of go wherever they want to. I believe that the plan is it will spend a while in Jezero Crater, and it has a lot of work that it can do there. Jezero Crater, we think, is one of the most promising areas on Mars for searching for evidence of past, or, knock on wood, cross your fingers, hopefully, maybe even current life. But scientists, it is a pretty big rover. It has, it is built with very durable wheels, so it'll be able to move on Mars for quite a while. The Perseverance Rover is also run by basically a miniature nuclear power station. Well, it's not like a reactor, but it uses a big ball of plutonium, and the plutonium gives off heat, which there's a generator in Perseverance that converts that heat to electricity, and it has enough power to last for quite a while, for I believe at least a couple years, and probably at slightly lower functionality quite a while, even farther than that. So I think that's at least the short to midterm plan for Perseverance. Is going to stay on Jezero Crater, look for any possibilities of past or even present life. It's also going to look for interesting rock samples to send back to Earth during the return mission. And I expect that NASA will keep it going for as long as they possibly can. One interesting thing that I think I've neglected to mention earlier, and this is actually something that NASA just announced a couple days ago, is that one of the things that they're doing on Perseverance is they have a couple little pieces of different types of fabric and material that they're thinking of using for spacesuits, because they want to see how that sort of material lasts over a few months on Mars, whether it deteriorates from Martian atmospheric conditions or radiation. So that's another sign that NASA is actually getting really serious about sending astronauts to Mars relatively soon. So they're using this as a test to see how those spacesuits might hold up under conditions on Mars. So another question is whether terraforming on Mars could be possible. And the answer is so the question is whether terraforming on Mars could be possible, and the answer is we don't know. There's a lot of interesting both practical and ethical questions that that are raised by that possibility. A few practical questions. One is, so the main thing for terraforming Mars would just be thickening Mars' atmosphere. And the main practical question is, where do you get the stuff to use to thicken Mars' atmosphere? Because if you get Mars' atmosphere thick enough, then it'll start to retain heat better, and that will and then it'll get warmer. You might be able to start having liquid water on Mars, and it would be sort of, not a vicious cycle, but the opposite, maybe a virtuous cycle where, Mars' atmosphere would then get thicker from other stuff after that, as water ice and carbon dioxide ice on Mars would melt and evaporate, and you could terraform Mars that way. And it's possible, there's even ways that we could start doing this right now. Like, if we sent like a bunch of CO2 to Mars and just sort of started having it spew into the atmosphere, that would start the process, albeit on a very, very small scale. One possible issue is that, whatever process caused Mars to lose its atmosphere is still, as far as we know, is still happening. So if we were to terraform Mars, it could very easily change back to the way that it was after we don't know how long. After, probably it'd be millions or hundreds of millions of years, but it could be faster than that. But again, there's a few ethical questions that are raised. For example, we still don't know if there's life on Mars. And if there is life on Mars, then what are, even if it's just microscopic life, then what are the ethical implications of terraforming Mars into a place where that kind of life could no longer, maybe could no longer exist, or where that life would have to change dramatically if it were to continue to exist. Another ethical issue is, if we were to terraform Mars again, it could sort of unterraform itself. As its atmosphere is still being stripped by sunlight, it could sort of de-terraform itself over, thousands or millions of years. And, there's an ethical issue of, if we did terraform Mars and then send people to build a civilization or something there, then what's the ethical implications of, sending a civilization there that might not be able to keep, who knows what state those people could be in a million years. And so what are the ethical implications of terraforming Mars if it might de-terraform itself and leave whatever life remained there in a kind of bad spot? So it's possible, but there's both practical and ethical issues to think about before we do that. So we're going to watch one more clip of this rocket boosting off because it's fun and it's a very significant event. We like to really sort of really linger on how cool it is. Oh, sorry. One more question. Is Mars's core still active? And we don't think so. We think that Mars's core used to be active. The geology on Mars and the rocks and the way, from what we've studied on Mars so far, it does seem that Mars used to have a magnetic field, based on lingering magnetic fields that we've been able to study in the rocks on Mars. And since on Earth our magnetic field is generated by dynamics in our liquid core, we would assume that Mars's magnetic field would be created in a similar way. But Mars doesn't have a magnetic field anymore, or at least this magnetic field is very, very, very weak, like something like a millionth as strong as it seems to have used to have been. So so that would imply that Mars's core probably cooled down and solidified sometime, nobody knows how long in the past, probably a billion years ago or more. And that might have something to do with why Mars's atmosphere has been thinning out. It's possible that Mars's magnetic field used to deflect some of the particles from the solar wind, and it's possible that after Mars lost its magnetic field, the solar wind started hitting it more directly and stripping its atmosphere a little bit more quickly. So yeah, we don't think that Mars has an active core right now. And it doesn't really seem, there's also lots of volcanoes, lots of extinct volcanoes on Mars. In fact, the largest, what's considered the largest mountain in the solar system, Valles Marineris, is an extinct volcano on Mars. But there doesn't seem to be any active volcanoes or any other kind of really active geology on Mars anymore as well, except for whatever geology is driven by its very thin atmosphere. So thank you for the excellent questions. I love getting those. And it seems that we're just about at the end of this. So we're going to watch the clip of the rocket one more time. I do want to remind everyone we do have an interactive stargazing this in about an hour this evening at 8:30 p.m. Arizona/Pacific time. Basically, we're going to open up our Geo Valley Open Deck Observatory, and we're going to see what we're going to use the telescopes there with some cameras hooked up to them to just sort of look at whatever we can look at. It's going to be a lot of fun, and we hope you all join us for that. But otherwise, we'll watch this clip of Perseverance lifting off one last time. Thank you again for everyone for joining us for this. My name is Kevin White. I'm with Lowell Observatory, and we'll see you all soon.
The Perseverance Rover headed to Mars, ready to ride a column of fire and smoke on its way to the red planet.
And liftoff. As the countdown to Mars continues, the perseverance of humanity launching the next generation of robotic explorers to the red planet.
And Atlas TU has gone to closed loop control. Standing by for SRB burnout shortly. And we have successful separation of Mars 2020 with the Perseverance Rover.
We now have an acquisition of signals to end the years of blood, sweat, and tears from every person who worked on this mission is now realized as Perseverance makes its way to Mars.